All right, so an ellipse we're going to be looking at today. We have both horizontal and vertical. I think chapter 6 and chapter, if not, let me give you this one because it splits it up. Thank you. All right, so like I said, this next slide is more so just to write the stuff down on your little chart thing, but the actual process of graphing an ellipse is 10 times easier than looking at all this. But you do need these little details. Let me move this here. Okay, so the horizontal ellipse stuff is to the left and then the vertical is to the right. So I'll give y'all a little bit to copy that down in the facts and all that stuff. Bless you. Because I think I'm still allowed to. Whoa, y'all notice the board's like this, like the projection of it? Not the board itself, but like the, they messed with the, I don't know how to fix that, but just kind of lean with it. basically, I know some of y'all are still finishing up writing that stuff down. Basically, some key points you want to keep in mind is that what are both of these equations set equal to? 1. Huge deal. If it's not set equal to 1, it's not an ellipse. Okay. Another thing to keep in mind, notice how this is very similar to when we wrote out the circles general equation. Right? The only thing that's different is what we're going to look at in a couple examples. I'm going to have you be able to spot out the difference. And the whole purpose of that is so that way we can kind of differentiate between all of them. So it makes sense that if you have your vertexes on your longer side and then your co-vertexes on your shorter side. So when I say all of these letters and formulas and things like that make it seem a lot harder than it actually is, I'm being very honest about that. Okay, so let's look at our first example. Well, okay, so go ahead and write that down. This is.
Real notes or chart?
I'm sorry.
Real notes or chart?
Chart, and it's on your horizontal. Anyone guess how I automatically knew it was horizontal? Because why? Okay, I knew it's an ellipse because of the 1, but how do I know it's horizontal versus vertical? Yeah. Without even using A's and B's, which number is bigger, 25 or 16? 25. That's underneath X, so that means X is going to be the longer axis, okay? So it's as simple as looking at that, and that's what I said, like, you can use A's and B's, you can use all those formulas, but if I have the bigger number underneath X, I know that's going to be my longer axis. So my center, that information has not changed. It's still going to be 2, -2. You always take the opposite. So let's plot 2, -2. Okay. What's the square root of 25? Go left and right 5. Square root of 4? Or 16? I gave you the answer. It's 4. It's how much you go up and how much you go down. That's what they said in a second block. So it looks like Hey Arnold.
It looks like a soccer ball.
Whatever.
We know how it was about soccer. Oh, Dave wasn't present for Dave's games on soccer.
Okay. So, what's the bigger number here? Okay, Y has the bigger number, 49. So then we know it's going to be vertical. So this is going to go under your vertical row.
This is hard. It's going to get.
Yeah, the only way this gets harder is when we're switching between the two forms. And that's because you're going to have to do completing the square with the leading coefficient. That's it.
So you just do 0.
So what is my center?
-3, 0.
Square root of -3.
Mm-hmm.
And the square root of 49 is 7. So you could remember all these things down here, like taking H plus or minus A plus or minus B and all of these things. But I would highly suggest just graphing it. And then that way, if I want to know what the vertices are and what the co-vertices are, it's easier for me to remember how to count left and right and pull that actual order pair out than remember, was it H plus or minus A, or was it B, or was it K, or was it, and all the things, okay? So graphing these and then pulling out the information is 10 times easier because, again, remember all the things we got to remember in general. This is something to not force. Okay, let's go back on our notes. Try this one. If y'all need a copy of the schedule in regards to what's testing when, I have it posted over here if you want to take a picture of it. I think she might have changed one of the bell schedules, but the bell schedule's up there too. You need to know for work or anything. All right. So what's my center? Now, something I would keep in mind too, which I made this mistake teaching the other day, is to put a C for center. I think that'll help because at one point I started graphing something and I started counting from one of the vertices and got real confused there for a second. So it just helps where you know to, okay, now from there, I'm going to go left and right 1 and up and down 2. Just a little one. Okay. Yeah.
What's the principle being taught here?
What's the principle being taught here?
Like with comics.
Like, what do we need it for, kind of thing?
Yeah, like under what scenario do you have 2 cones that are being cut by a plane?
That's a great question. I do know you need this in calculus. Do I know specifically what it's used for in calculus? No. That's one of the reasons, again, why I'd like to teach calculus, because I'd like to know what it looks like. Because it's easy for me in Algebra 2 to tell you in pre-cal you're going to be using this because this. But I can definitely find that out for you. Okay.
How disgusting.
I don't like this.
It's like that.
What's wrong with this problem?
Everything.
Nothing much
It's
really.
not the way.
It's not the way we do things.
It's not the way we do things.
Yeah, what the heck?
How can we make it look like things we do?
No solution.
There is a solution.
Ask someone else. Oh, we divide the 225.
There you go.
Pythagorean theorem.
No, not Pythagorean theorem.
Same thing.
So if we divide by 225, that's why I said at the beginning, one of the main things you need to focus on is that this needs to be set equal to 1. Now, if you divide this out and it doesn't look like we need it to, then that's a different scenario. But 25 over 225 and 9 over 225 both reduce. So what is 25 over 225 reduce to?
1/9.
1/9. So this would just be x squared over 9, which makes this y squared over 25. Now it looks like something we're familiar with.
Sure.
You think that.
It's just that it's just you want us to graph it.
Now we just graph it.
Okay. I think we should get paid for school.
You know what? I think I should get paid for teaching.
Don't
Yeah,
you?
that's true.
Do I though?
I've always
You can
wanted
buy
to
a
pay.
sandwich.
Honestly, I would be fine with just like incredibly good lunch food.
Okay.
Like we need a gourmet chef in that.
Yeah, I want to gourmet.
Do we have a
Yeah.
price chef?
You know, there's some schools that don't have food given to them, period.
Yeah, my
Right.
there's Texas that has food courts in their schools.
Yeah.
There's also
It's kind
those
of
in
real good.
Nashville.
They also have rolling blackouts.
Yeah.
They get a horrible infrastructure.
Yeah, but most.
Good one, Dane.
But-
Thanks for the validation.
Texas, but they're good at football.
Yeah, good football.
Don't be hate on the cheesesteaks here.
Nah,
Where's
everything
the cheesesteaks
sucks.
go?
I think so.
No, the cheese bites.
We get excited about the worst food ever because everything else just sucks even more.
I know, their chicken sandwiches are good.
Debbie, did you wake up on the wrong side
No,
today?
he's telling the truth.
Yeah.
I'm just a realist.
I'm just a realist.
You're not
Go back
wrong.
to dating years and make it-
I would pack my lunch if I had lunch, but that's a lot of effort, so.
At Bearden, they had a French fry bar. That was all that really was offered. That was good.
My brother was in middle school. They had like pizza from like Domino's and stuff. And
Yeah.
milkshakes. And now they don't have any of that. People have that.
They used to have
Is there someone we should like call about
Michelle
this?
Obama, the one who did this.
Yeah, I want to be on her.
All right. So, like I said, the easiest way to approach a lot of these problems is to graph, then memorize. Okay. So, when we're trying to remember our formula, again, there's pieces that I don't want you to forget, and that's that plus sign, and that equals 1. I always remember this because this is going to be the same layout for a hyperbola, which is the next thing we're going to do. But then it's going to have a minus sign here. But the plus sign makes me think of me drawing an ellipse, if that helps you remember which one has a plus and which one has a minus. So we have X and Y. So our center is -4, 1. So this becomes a +4, and then of course a -1. Now, when I'm looking at this, for me, it's a whole lot easier to do a little sketch off to the side. So if that's my center, then I have a point at 1, 1. Now I know how much I went to the right. Okay. So then if I went to the right 1, 2, 3, 4, 5, I know that this becomes 25. So I went to the right 5 spaces, square that, I get 25. Then I know if I plot the point -4, -3, then I know I went down 1, 2, 3, 4. So down meaning y, square 4, I get 16. So again, for me, a visual representation of the 3 points they give me, and this is where I screwed up because I started counting from another point. But that's, to me, what helps to be able to write the equation from the given points. Okay. Questions on that so far? And again, that equals 1 is the thing people miss the most, and you lose points for that because that's not the entire equation. And yes, you do have to know these equations for the test. So try this one. Okay, so I start off with my little skeleton here. And I have x minus 2 squared or x, there's that other mistake, y minus 3 squared. So if I'm plotting at 2, 3, and I have a vertex at 2, 0, how much did I go down? 3. Square that, I get 9. And then at 0, 3, how much did I go over? 2. Square that, get 4. Okay. All right, so let's now change between the two forms because like I said, on your test, the first part of your test is going to be matching. And it's going to have all the equations, whether they're going to be in general form or standard form, okay? Some of y'all will be able to recognize what each one is in the form that's given to you. Some of y'all will not, so you'll need to change it to the other form, okay? So let's check out the first one. We are going from having not only parentheses and fractions to having everything set equal to 0, not parentheses and not fractions. So basically, I need to think of a number I can multiply everything by So the denominator goes away. What's that number?
36.
36. Because 36 over 9 reduces to 4. 36 over 4 reduces to 9. Go ahead and double distribute. Distribute your numbers, combine like terms, set it equal to 0, all the things. So 4x squared plus 9y squared plus 16x plus 36y plus 16 equals 0. Okay, just some good old algebra, multiplying, combining like terms, all the things. Okay, huge idea here. Show your work so I can give you as much partial credit as possible. Okay, because there's a lot more room for error here, I do want us to do that second one. Go ahead and do the second one as well. See if you can knock that one out. And then we'll go the opposite way. Hey, Dane, on your, was it Fred? Was that his name?
Whatever you want it to be.
Okay. If I take the push pin out, I should be able to, it won't mess up anything and I can just flip it.
Yeah.
Okay. I just gotta cover up the circle part. Let me get Fred. What number did y'all multiply by? And 144 over 36 reduced to what?
Yes.
4. Any questions on that? Did I do something wrong?
4 times negative 20 equals negative 8.
80.
Yeah, I was like, something's not right, but I can't tell what.
On my desk is actually, let's start cleaning that up. Let's put it back here. Thank you. It won't be next week, but the next is when that will start. So I'll have to like help cover up. math things. All right, so let's go the opposite direction. Okay, so we are going to complete the square twice. We're going to first move everything together with an X and then everything together with a Y. And remember, with completing the square with the leading coefficient, again, it's a little bit different. Now, if you can look back on your notes pretty quickly of the notes we did the other day. Okay. Look at the difference between this equation here and I guess it's the general equation. The general equation here versus the general equation with the circle. What do you notice is the big difference?
And the leading coefficient.
They have leading coefficients. Okay. The circle one was just x squared and y squared. Their leading coefficient was 1. Okay. So then in this case, that's again a little hint versus circle and ellipse. All right. Then when we're going to look from an ellipse versus a hyperbola, then we're going to have one of them is going to be a negative. Okay, and that's going to tell us the difference between all of those formulas. Okay, so I'm first going to move together my x's and my y's. It's like going backwards on everything we just did. And move my 16 over. And then we're going to complete the square twice. So remember, with a leading coefficient other than 1, I have to take out that 4 first. And I take out my 9. Sounds like my computer's about to take off. That's just running the recording.
I think they use those big smatters they have.
Right?
Is it too strong of a festival?
Anyone else feel strongly about that? It's me. All right, so if I take b divided by 2, I get 2, and then I square it, I get 4. 4 goes here, but what goes over here? 16. Okay, remember you have to multiply it to the number in front. Same thing over here. We take b divided by 2 and square it. So we get 2 squared, which is 4. And 4 goes here, but what goes here? 36. So then we factor. And we get 4 times, so if we have multiplies to get 4, to add to get 4, it's just 2 and 2. Then we have same thing, y plus 2. And that should equal 36. But what's our main thing with all of these formulas? Has to have that 1. So we're going to divide everything by 36. So literally these last problems are pulling everything together that we've done algebraically throughout this whole lesson. Any questions on that?
No, it sounds hard. That's what, that's hard to learn.
Excuse me, what?
His hand's tired from writing.
Oh,
Learn.
The parts are you like filling the form and then he's just going to use this to go over that yesterday? Like, wasn't
With the what goes in this spot? Okay, so it was, yes, I did go over it yesterday, but it's also what was in our chapter 2 and all the things, but yes. So, you're just gonna take your B, divide it by 2 and square it. So in this case, I would take 4 and divide it by 2.
That's hard.
I don't know why we're verifying Microsoft Word right now.
they know how much you like to write.
I love writing.
You want to read it,
I love reading. I love writing.
If I started writing out like 9 and 4 like in the letter form, would you count off?
Aren't you
100%.
sure it's all different, but
Yeah, you write out your.
Like 9.
Last year, Dave wrote me a novel for a project, and I was like, no, I'm not reading that.
so why would you do that? Because it says it's oh yeah.
So this is like good old school completing the square using their A's and B's, not the A's and B's up here. So then we used to always show our work, the whole process, because then this number always was that number.
Would you like Alice have to do a problem like that and then take that and then graph it? Just for fun.
Possibly.
sounds like a lot.
It just sounds like a full problem.
It's just
It's almost.
It sounds like a word.
And on the next slide, I'm just kidding. That would have been a good problem though. That would be a good closer. Like, you know what? It's like, do this, break it down, then graph it. It is literally like all in one. If you could do that, then you're good to go. And then do it backwards.
No. What? Are you just gonna show us the graph and have them do the rest?
Yeah,
Good.
these are great ideas actually.
Matthew.
And I'm not being sarcastic. I know I have a smile on my face. I'm not being sarcastic. That's a good way to like solidify everything. All right, try this one.
Since I gave you
Look
such a
at
good
me in the eyes
idea,
and apologize.
since I gave you such a good
What
idea,
if I don't want
I'm gonna
to?
expect.
I don't consent to this problem.
Oh, listen, there's always a catch with you. Since I had a great idea.
4 looks like a 9. It's okay.
Okay.
All those.
Little do you know I do that anyways.
Okay.
Question, isn't this the latest?
Do it hard school mode.
Try it backwards. Skip all the steps.
There's a purpose.
You want to see this one?
Yes, please. Now you try.
No, we were just looking at it.
I just didn't do that.
No, we're just looking at it.
I have issues.
I have issues with math.
No, wait.
Same.
What?
Specifically people who know.
What's 100? No way.
Yeah, that's actually exactly what it is.
No way.
No way, Matthew.
Yeah.
I thought it was wrong. That's crazy.
You guys are
64.
missing.
are a
That's what that one is too.
We're the mess?
We're the man.
Hey,
I'm the man.
Sorry, that was.
wait a second. How did that become about me real quick?
Ask him.
That's me.
You meant Aiden, but if you want to take it personally, that's okay.
This problem is very familiar.
I swear I've seen this before.
It's usually like a ripple effect. Takes everyone a minute to catch on.
25.
It's like 144 big.
Hold my pocket.
Did you do it? Did you set it equal to 1?
Yes.
Okay.
I just copied the step. I added 64 to 400 in my head.
Good.
It's difficult.
Yeah, the other side.
I did.
You missed it, not you.
That was pretty right.
There's no wire. Why you picked one?
That's fun. Good, so that
No, you weren't kidding. You should get canes right up there, though.
Isn't some at UT miles?
Canes will have to It's better than Texas. It's better than Texas. I'm not kidding.
Essentially, it's good stuff. And the salads. They don't have salads. Yeah, they have salads.
Really
They
good.
have salads.
Shut up. You know,
He thought it was funny.
Matthew, don't give him credit for that. He doesn't need validation.
The funniest part was your guys' reaction to it.
It's a terrible joke.
He knows me.
Hey, that's what I got.
Whoa.
Crazy.
Must be right then.
I totally didn't
Yeah.
just write down the thing. I know.
That's what you do a test. Put one of this and so that basically you do that.
Put the inverse as
Right.
the next problem.
I guess you
Yeah.
can do it.
Y'all are full of suggestions today.
I think you should just give
And then, like,
us
curve
one
every
for
test.
Curve all the
The
tests.
Texas curve, so it's like Texas curve.
Square root curve.
Okay.
Just-
I'm on it. I am here for you.
Isn't that is technically true, I think. You do
I
all
show
the-
up every day for you.
You do
Whether
it
y'all
like
do
2
is
times.
different. Okay, yes, that was exactly
If I showed up just for you, I'd be scared.
true. True. Maybe just the blanket statement of show up for teachers,
Good one, Dave.
I guess. Yeah. Yes, that was the complete opposite of what we've already done. Okay. I've got 4 more examples if you would like to do those. If not, go ahead and get started on your homework.
Oh, I think I'll pass today.